Guys, Mr. Gibson. I'll show you guys how you can determine whether events are independent or dependent of each other, okay? And dependent is just opposite of independent, so I'll give you guys the definition of independent. Independent means two events are independent of each other if in no way one event affects the probability of the other event occurring, okay? It's dependent if one event affects the other event from occurring, okay? So that's just kind of a little basic definition that we've gone over in class. What I want to show you guys today is how you can show independence. The first thing you can do is events are independent when you have events A and B. If you multiply the probability of A times the probability of B, you get the same probability as if you calculate the probability of the events occurring together. That's what this AND means, okay? And I just showed it over here too using the set notation for AND, okay? These two things mean the same thing. I just wanted to put that out there. But so what this means is if I calculate the probability of both of these events happening together, okay, and then I take the probability of event A happening times the probability of event B happening, and they're both equal, they're independent, okay? So that means, you know, A is not affecting B, B is not affecting A in any way, so if you have their both individual probabilities multiplied together and you get the same thing, well, they must be independent. Next way to show independence is using something called conditional probability. We'll talk about this in more detail in the next video, but I'll give you guys kind of the basic definition here. It's the measure of probability given, okay, that another event has occurred, okay? So if an event has occurred, what's the probability of this event happening? So with events A and B, conditional probability is denoted probability A. This little line right there just means given B. In other words, the probability of A, okay, occurring given that B has occurred, okay? So events are independent when the probability of A equals the probability A given B. So what this means, you guys, is given that B happened, if I calculate the probability of A, given that B happened, and it just equals the same probability as A, that means there was no effect from B. B had no effect. So B has no effect on A. That's basically what this means, because if probability of calculating A is the same as the same probability that you got for A given that B happened, well, B just didn't do anything to it, okay? That's the basic idea here. So, let's look at an independent event, okay? A cooler contains 13 bottles of sports drink. 5 are lemon lime flavored, 4 are orange flavored, and 4 are fruit punch flavored, okay? You randomly grab a bottle, then you return the bottle to the cooler. Mix up the bottles and randomly select another bottle. Both times you get a lemon lime drink, okay? So, event A was that you drew a lemon lime drink, okay? And then event B was the same thing, okay, so except then you got another lemon lime drink, okay? So the probability of drawing a lemon lime drink first was there are 5 lemon lime drinks out of 13. Well, the probability of drawing a lemon lime drink again was there were again 5 lemon lime drinks out of 13 because you replaced that bottle. Okay, fair enough. So let's calculate this. Let's calculate the probability of A and B, okay? So the probability that A happened was 5 and 13, okay? Because you had 5 lemon lime drinks out of 13 bottles. You drew it, well then you put it back. So again, after you did it the first time, there were still 5 lemon lime drinks and 13 overall drinks. So that should be 5 times 13. Okay? That is 25 out of mind drawing a blank right now. 13, 1. Let's see, 13 squared. Let me just do 13 times 13. I'm losing my mind again. 3, 0, 3, 1, 9, 6, 1. Done. Okay. 169. So, that was the probability of A and B. Well, duh, it's the same probability that I got from A times probability B, because that would just be 5/13 times 5/13. So obviously these are independent, okay? Well, let's look at it with conditional probability. So it's probably easier to think of this way with B given A, okay? What was the probability that B happened given that A occurred? Well, A, you drew the lemon lime drink, but it really had no effect over the overall probability because you replaced it. So it's just it equals the probability of B. Okay, so given that event A happened, it didn't really affect the outcome of B. All right, that's the general idea here. It might be a little easier to see all this because this seems kind of silly when you look at it when an independent event is. Let's look at a dependent event. So there are 4 boys and 4 girls in the class. The teacher randomly selects one student to answer a question. Later, the teacher randomly selects a different student to answer another question. The first student is a boy, the second student is a girl. So A is picking a boy, and B is pick a girl. Okay? So probability by itself. So the probability of picking a boy was 4 in 8. Okay? So 1/2. And then the probability of picking a girl, there was 4 girls out of 8 students, so again 1 and 2. Okay? Now, let's go through this scenario. Let's look at A and B though. Okay? The probability of picking a boy first was 4 out of 8. Okay? And then picking the second as a girl, well, she's not going to pick the boy again. Okay? So there's still 4 girls she can pick, but there's only 7 students that she can pick. Okay? So that's 16 out of 56. Okay? Which, reduces down to 8. So, well, no, don't need to reduce it. Anyway, so 6 out of 56 chance. But if I did A times B times the probability of B, that's just going to be 1/2 times 1/2, which equals 1/4. Well, 16 over 56 is not 1/4. So these are not equal, which means they have to be dependent, which that makes sense. The fact that you take away one option for the teacher to select means that having had a boy be picked first, or anybody picked first, affects the probability of picking someone after that. Okay? Well, let's look at it conditionally. So again, probability of B picking a girl is 1/2. Okay? But what's the probability of picking a girl given that a boy's already been picked? Well, that is, as we've seen right here, 4 out of 7, which is not 1/2. These aren't equal to each other. So again, as you guys can see, the fact that you pick somebody and then you're not going, you don't replace, you just keep that person out of the future possibility, it affects the outcome or affects the probability of the next scenario happening. So this is a dependent event. And just this little bit of math here is just to verify what we already kind of understand intuitively or understand in our heads about an independent and dependent event. Okay? So the notes will be on the next page, and you guys do the assignment. Thanks.